Welcome to this month's Ingredient Spotlight. I'm Dr. Vanessa, and today I'd like to talk about cellular autophagy. Now, autophagy is our natural process for cleaning up and recycling cellular debris. Now, this is a process our cells use to help remove metabolic waste and toxins, but it's consistent activation of autophagy that increases lifespan in preclinical models of aging. Now, studies show that fasting and exercise are effective ways to induce autophagy, but these can be difficult to maintain long term. So, this does pose a problem because autophagy activation can decline as we age. And as this happens and cellular waste starts to accumulate, this can lead to diseases like neurodegeneration, metabolic and cardiovascular diseases, infections, inflammation, and even cancer. Now, the solution may be found in two herbal nutrients. Using advanced AI technology and preclinical research, we've identified a long pepper extract called piperlongumine and a flavonoid called luteolin, which is found in parsley, but can also be found in like thyme and celery and other vegetables. Now, how piperlongumine works is by activating autophagosomes. Now, these are like garbage bags where cellular waste is collected, broken down, and recycled. In order to activate these garbage bags, a protein called Beclin 1 needs to be freed from BCL2, as seen here on the diagram. Now, when Beclin 1 is bound to BCL2, the garbage bags are inactive. And this is where piperlongumine comes into play by helping to release Beclin 1 from BCL2 to activate the autophagosomes. Now, once the autophagosomes are activated, lysosomes can join, which contain enzymes that start breaking down that collected metabolic waste. Now, how luteolin works is by promoting AMPK activation and lysosome biogenesis, which is a process of creating more lysosomes. More lysosomes help to enhance the effects of the autophagy. But let's take a look at some preclinical research. So this is a proof of concept study assessing the effects of piperlongumine on autophagy in mice given a neurotoxin called rotenone. Now, rotenone creates Parkinson's-like movement issues. So the researchers divided the mice into 6 different groups. Groups 1 and 2 did not receive rotenone. Group 3 only received rotenone, and groups 4 through 6 were given rotenone plus a treatment intervention. It's the group 4 and 5 that were given the piperlongumine, but at different doses. And the last group was given L-DOPA. Then the researchers had the mice perform tasks. And one of the tasks is called the Rotarod test. So this is assessing how long mice can stay on a spinning horizontal rod without falling off. And the pole test is assessing how fast the mice can climb up and down a vertical pole. As we can see from the graphs, groups 1 and 2 performed the best since they were not given the rotenone. However, if we compare group 3 to the piperlongumine group, the piperlongumine treated groups performed better. And why we're seeing this improved performance is because piperlongumine may be inducing autophagy as seen in this last graph. This graph is measuring LC3, which is a marker of autophagy, and this is highest in the piperlongumine group. For this next preclinical proof of concept study, the researchers were evaluating the effects of luteolin on mice with traumatic brain injury. Now, the graphs to the left here are measuring markers of inflammation, and the graphs to the right, or the graph to the right, is measuring LC3 again, which is that marker of autophagy. We see that the mice with traumatic brain injury given luteolin had less inflammation and increased autophagy. So, who would benefit from this novel combination of piperlongumine and luteolin? Well, longevity enthusiasts who are looking to target several ways to promote more consistent autophagy and to support a healthy lifespan and promote whole body cellular detox. I'm Dr. Vanessa for Life Extension. Thank you for listening.